My name is Dr. Marina Milner-Balodin. I am a science educator at the University of British Columbia. And today we're going to talk to you about eddy currents. I just would like to remind you that we discussed earlier the law of electromagnetic induction by Michael Faraday. And this law told us that as soon as we change magnetic field through the coil, electric current will be generated inside this coil. And you can ask the question I hope you see that the needle is moving. Electric current is generated in the coil, and you can ask, but what is the direction of this current? And according to Faraday's law, the direction is always to oppose the change that is caused by the motion of the magnet. Now, let's think, what does it mean? And to do that, I would like to show you what happens when I have three inclined planes. I have one made out of plastic, one made out of aluminum, and one made out of ferromagnetic material like iron. And what I'm going to do now, I'm going to use two materials. One is a magnet, and one is a piece of copper. It's just painted, so it is a non-magnetic material. So let's first let both of them slide across the inclined plane made of plastic. You can probably predict that how they slide will depend on the friction between the two surfaces in the plastic, and probably it will be pretty similar. You can see there is a little bit more friction here, but they both slide down. Now, what happens if I put them on a ferromagnetic material? Then, if I do it here, I put the iron here, and I put the magnet here, and I put this material there. You can see that one falls because it is a non-magnetic material, and yet the magnet is attracted to it. It's the same idea as you have it on your fridge when you stick magnets on your fridge. But what will happen if we put it on the aluminum? Aluminum here, you know that it is a non-magnetic material, it is a metal. If I put this, it just slides. But how will this one slide? Now let's think about it. This is a magnet, and when the magnet is going to slide, the magnetic field through the aluminum, you can imagine as if we had lots of tiny circles. You can even imagine as metal circles along the aluminum. Those circles will experience the change of magnetic field through them. And what will happen? Electric currents will be generated in those circles. Those are called eddy currents. And those currents will slow down the magnet. Let's see it. Once again. You can see how slowly the magnet is moving across the aluminum, and yet aluminum is a non-magnetic material. The magnet is not stuck to it, yet it is slows down extensively.